about like a 15-second delay?
Yeah.
You said slow.
I don't know.
Did you make a recording? Oh, you. So it started streaming and then you cut the broadcast. It's now saved.
Wait, what?
Are you streaming right now?
Yeah, I think I'm streaming.
So there's right now a 16 sec. Oh, this is it.
All right.
Okay.
Is there audio?
It's loading.
Oh, that sounds like a yes. Okay.
It's a.
Great.
You have to turn your mic up because. I mean, people can turn the volume. You're just barely.
I'm just
your
barely.
Noise to your signal to noise ratio isn't great.
Oh, as in the room is noisy?
Yeah, or just the regular noise from the screen itself. Do you have an external mic by any chance?
No, I don't.
Do you have? It's so stupid. Do you have a Bluetooth headset? I guess.
Do I have what?
Wear a Bluetooth headset. That's just straight.
I have my headphones, but
That was my first thought, but like, yeah, if you just.
I think this is just how it's gonna be. All right. Hello, Twitch. People are still getting food, but we'll start in a couple minutes.
Speak at a normal screen noise. Speak at a normal.
Well, I don't want to like yell if there's nothing important to
So
say.
you're gonna be like, you're not gonna be in front of your. Are you on your laptop all the time?
Yeah, mostly because I'll be typing and stuff.
Okay. This is. I think it's the best we can do.
Okay.
And like, if you don't have headphones, then.
Yeah. Can you No, don't do that. Also,
There's enough delay.
15 seconds is too long. Then
It wouldn't amplify. It just sound funny.
Yeah. Okay, great. Do you want to grab?
Recording, by the way?
Do you want to grab your laptop and stuff? And
Yeah, I just remember.
and actually, yeah. Can you cause a merge conflict in a repo that I just made for teaching purposes? No, cause a merge conflict so that I can show people Git.
I was so curious.
Yeah. I'll tell you what I want you to do.
What's the
I'll add you to it. What's your GitHub username? So N what?
Sorry. Letter N. Digit 8.
Oh, Nate Kim.
Number 1. Yeet. Yeah.
Okay. Okay. I'll tell you where I want you to make it. How do I... What?
Never want to be named for that anyway. Also, I just realized we can maybe rent a mic for maybe.
Oh, yeah, maybe. Hey, guys in the back, is this readable from back there? Both sides? Yeah? Okay, great. Okay. Just one is fine. But thanks.
What do you think war would be better?
Okay. Do one of you have Twitch open to watch for questions and stuff? Is there a way for me to see the chat while I'm streaming, or I guess I could look on my phone. Yeah. Is it?
When you try this later, you can get Twitch chat doubles like
Wow. No, that's alright. Yeah, I'm not that pro. Yeah.
It's not really practical. Unless like someone decides to go with you.
Yeah.
Yeah. Wait, really? For it to be a company. You did your part. Oh wait, no. Schedule on. Remember that time zones thing?
Yeah.
It's coming back to life. Oh, hello, long time no see.
Yeah. Yeah, I have the receipt. Okay, let's go ahead and get started. Feel free to like get second rounds of food and stuff as it goes on, but I'm gonna start talking now. So first, some updates. The spec has been updated to talk about cows, which are very important and somehow I forgot to write about yesterday. Also, the effect of pollution on vision radius, and then some other like small clarifications about like whether drones can pick up drones, movement and spawn restrictions, stuff like that. So those are all in the spec now. There are a couple of more minor edits that should go into the spec tonight, but no like game changes or anything. I was wrong yesterday about drones being able to pick up drones. They cannot. Sorry. But yeah, okay, so that's how things are. Also, there have been like some engine updates and client updates, just like mostly bug fixes and tweaks like now the client shows vision radii correctly if you click on a unit, stuff like that. So make sure that you are doing Gradle update and Gradle build from time to time. I could just like, okay, fine. Like this. Oh, I'm in the wrong place. just do this from time to time. It'll download the new versions of things, and then you'll have the new up-to-date client and all that good stuff. And we'll also try to announce every time we make a change that requires you to update the engine and client and stuff. But yeah, okay, so those are some updates. Scrimmages will probably come online later tonight, so stay tuned for that. But now, without further ado, I'm going to talk about how to use Git to collaborate, and then we'll start doing that and improving example funcs player so that it doesn't just move randomly and get flooded. Okay, so collaboration, very important, right? Perhaps yesterday you got together with your team and you're like, all right, we need to like work on some file together. Let's use Google Docs, right? Because that's what you use to collaborate with people on documents. This is a mistake. I did this my first year of Battlecode, and it was bad. We had a 53-page Google Doc, single-spaced 8-point font, and that was our entire program. And it was terrible. Changes got overridden sometimes. If you like copied and pasted the whole thing, Google Docs would crash. And like, it was just bad. Never use Google Docs to work on code together. This is a solved problem with something called Git, which is awesome, and is the way that you should collaborate on code. So I'm going to show you that. There are a couple of basics for Git, but to get you into the, we have some setup to do first. So if you don't already have one, you should make a GitHub account, which is a nice cloud provider that can host your code for you and make it easier to collaborate and like sync things with other people. So I've made an example Git repo on GitHub called lecture player. Mine is public, but you want yours to be private so that other teams can't see your code. And so you'll create this repo. It'll be empty. You'll go into settings and go down to collaborators and just add other members of your team. For example, I added Nathan because he has the same name as me, and so we should work together. But yeah, so you'll have a private repo with other people, and then it'll be empty. So how do you start adding code? Right now mine has robotplayer.java, but that's because I added it. Yours will be empty. So you'll go here, and then you'll copy this link. I can help people get SSH set up after the lecture if they want, but the basic way is to use HTTPS, and then when you try to like push and pull code, you'll just have to type in your username and password for GitHub, and then it'll work. There's a setup where you don't have to type in your username and password using SSH. I can help you set that up afterwards, but I'm not going to show it now. But that's what I have. So then you'll go into your scaffold. So we'll, actually that's not what I want. So the scaffold is right here. This is what it looks like. I'm also going to be using Unix commands, which may be unfamiliar if you use Windows. So ls just lists all of the folders inside a folder. So the folder name is Battlecode 20 Scaffold, which is the thing that you all should have like downloaded and stuff yesterday. If you haven't, that's fine. Just follow the instructions on the Battlecode 2020 site. So yeah, ls shows you what's in here. So this is what the Battlecode Scaffold folder looks like. And this folder, src, is where all the robots are. So I'm going to use cd to change the current directory to src. And now if I ls again, I can see example funcs player and lecture player. So you're not going to have lecture player. You'll just have example funcs player. But to clone your repo, which is one of the first Git commands that we'll see, you type git clone. Oh, and I just did it a second ago. It's been being revealed. Git clone, and then the link that you copied. So if you want to clone lecture player, it's exactly this link that I have here. If you want to clone your repo, it'll be whatever link you copy from GitHub. But you execute that command, and then you will have this lecture player folder. And so inside that lecture player folder, right now I have a couple of things. Yours will maybe empty or just have a README. But the first important file that you want to make is robotplayer.java. because robotplayer.java is the thing that the engine's going to look for to run your bot. So if we look inside robotplayer.java, right now, all I've done is copy example funcs player exactly. So here they are. The only difference is the package name. And the package name just needs to match the folder name so that the engine can import your code properly. So yeah, don't forget to change that first line. But otherwise, they're the same. Okay, so we're starting with that. And now I have robotplayer.java in here. Great. And since I've already done a little bit of setup, I don't have any unsaved changes or anything. If I type git status, it tells me I'm up to date. I'm on the branch master, which is like the default place where you put code. I'll talk about other branches a bit later. But right now what matters is that we're up to date and our working directory is clean. We have no unsaved changes. If I make a change like this and then I save it and I try git status again, it'll tell me, oh, you've modified robotplayer.java. These changes haven't been synced with the remote server, which is GitHub. So none of your collaborators are going to know about it or anything. And you need to do something about that. I don't want that change, so I'm going to get rid of it. So we have, so git status is the first thing, and or the second thing. Git clone to clone the repo, git status to see your status. I can do git status again since I removed the change, and it's clean again. Okay, so before we learn how to like save changes and stuff, let's make a change that's worth saving. So right now, if you remember, we are moving around randomly. So if I run a game here between example funcs player and lecture player, which is now an option on central soup. If I do this, both of them are going to do the exact same thing, just moving around randomly, not terribly intelligent. And obviously we want to change this behavior, right? We want to improve on example funcs player. So as the first thing, let's just make miners pick up soup and see if we can get that to work. So we'll go down to the run miner function. And okay, so let's see what's happening here. First, it's going to try the blockchain. We can leave that alone because that doesn't really matter. And then it'll try to move. And if these move, so it'll try to move twice actually. And so if these moves succeed, then the robot's going to have cooldown and it won't be able to do anything else, like try to build a robot or try to build a fulfillment center or try to refine some soup or try to mine something. None of that's even going to be worth trying if your cooldown is greater than 1, which will be true if you just moved. So let's move second, because it's much more important. If you have some soup to deliver or some soup to mine, that is way more important than trying to move randomly. So we can just take this block and we'll put it at the bottom. So now, and then I'm also going to remove. Let's not worry about building buildings yet. So I've just removed a bunch of code. So now the first thing that we'll try is we're going to loop through all the directions and try to refine in that direction. So all try refine does is it just checks if you can deposit soup to a building in that direction. And if you can, then you do. Otherwise, you don't. So what that'll do is if we have soup to deposit and there's something that can accept soup nearby, then we'll just put soup in. Otherwise, it won't do anything, and it'll try that for all the directions. So that's fine. That's probably the most important thing. We want to do that first if we can. But if we can't deposit soup, then we want to try all the directions again and see if we can mine some soup in that direction. So this will try every tile in a circle around us, and if there's soup there, then we'll mine the soup. And then finally, if none of those actions worked, we'll try to move every time, but we'll have cooldown if any of those worked, so it's not going to happen. But then we'll try to move in a random direction. If no other actions have happened, then we'll have cooldown less than 1, and we'll be able to move. And I'm also going to remove this line because we don't need to move twice. So yeah. Okay, so then it'll just try to move, and if it moves, it'll say that it moved. Otherwise, one of these other actions must have succeeded. So if we run this same game again, we can see that my laptop is slow. Okay, so if we run the same game again with our updates, lecture player, which is team B, the blue team, because A is for blue, or A is for red, B is for blue. We're running the game, and okay, here we go. So now, sorry, it's really slow because I'm also streaming. But all right, here we go. So the game has started. We've produced a couple of miners. They're running around. Oh, and this miner now, if we look at his logs, so we can click on him to see the logs, the vision radius, and stuff like that. Okay, so he says he's mining soup. We have this print statement here on turn, what is this, turn 27. It's probably too small for you guys to read. I'm not sure how to make the client bigger. But anyways, it's printing out this thing right here. I mined soup. So that's great. And we can see, if we let it go a little longer, that piece of soup disappeared. And if some other miners move close by, then maybe we'll see them mine some soup too. Oh yeah, here we go. So that guy was mining some soup. And now this one's mining some soup. And so now we've seen, okay, so it's working. They're mining soup now instead of moving first. And this soup deposit over here is getting depleted. So that's great. And it looks like some of them are even depositing if they happen to go back towards the HQ. But this is great. Okay, so we have some changes that are worth sharing with the rest of our team, right? So they now die just as soon, but at least they mine some soup. So it'll win the tiebreaker of most soup or something like that. You can see the blue team has way more soup than the red team, which is good. We're already doing better than example funcs player. So let's go back and commit our changes. I'm going to close the client because I have too many things open. Okay, so we've made some changes. If we say git status again, then it'll tell us we modified robotplayer.java. Another really useful command is git diff, which will tell you what has changed since your last save. So we can see that I've deleted a bunch of lines up there. That's what the red means. And I've added these 2 lines down here. That's what the green means. And these are the only changes that we've made since the last commit. So, okay, so there's a difference between saving your code and committing your code. When you save your code with like Control S or whatever in your editor, that just saves it locally to your computer and like changes the file and whatever. That doesn't save it for Git. Git has a different sort of save abstraction called commits. And so commits are less frequent than saves. A commit is like a snapshot of a new sort of version of your code. And what's really cool about Git is that unlike saves, like file saves, you can actually go back through the entire history of all commits ever. So if I type git log, I can actually already see these are all the commits that I've made. So earlier today I did the initial commit where I created the repository, and then there's this other commit where I copied example funcs player. Then I forgot to update the package name, so it didn't work, and I had to make another commit here. And then I added some instructions to the README, and that's this commit. And we can go back and look at any of these commits. So if I copy this right here, or actually I'll show you, I have unsaved changes, so it won't let me yet, but I'll show you in a second. Anyways, so this is the like entire history of the project. And so this is really great. If I make a couple commits now and then like it turns out the bot gets worse, then I can go back in time to an older version of the bot and just restart from there, or like copy some changes from there and put it in the new version, something like that. This is what Git is really for, which is version control. Managing different versions of the code and keeping yourself sane as different people make different changes all the time and are trying to combine them. So now we want to commit this code because we've saved a couple of times and we've made our changes and stuff locally, and we're now at a point in time where we want to share these changes with the rest of our team. So git status has told us we've modified robot player. Git diff has told us what the changes are, and now I'm certain that I want to share these with the rest of my team. So I'm going to type git add, and I'm just going to use a shortcut -a, which is all. So add everything at all that has been changed. And the reason that you have to do this is because it's possible to commit different pieces. So for example, if I change the README also and saved this, and then I type git status, it's told me, okay, I've modified two things now. So if I git add robotplayer.java, now, and I type git status, it tells me, okay, so this is ready to be committed. If I type git commit right now, then I'll only commit the changes to robot player, and the changes to the README aren't going to be shared yet. I can keep working on that on the side and whatever, or keep it separate in a different commit because maybe I want to do that. So that's what git add is for, is to say exactly which pieces you want to commit, because maybe you don't want to make all of your changes at once. I don't want this change, so I'm going to undo it. And now if I type git status again, I haven't modified the README anymore because it's the same as it was before. So I've saved the README a bunch of times, but since this copy is exactly the same as the copy in the last commit, there are no changes to be committed. Everything is fine as far as git is concerned. Okay, but now we've added robot player, which are the changes that we want to commit. So we can type git commit, and I like to do it all at once with -m to make a commit message all at the same time. If you just type git commit, it's going to prompt you to enter a commit message here. So I can type it in like this and say make miners mine soup. So that's the change that I made. So now I can write this commit message, and we've made a new commit. So if I look at the log at the top here, I can see there's a new commit, which is the one that I just made. If I type git status, it says you're on branch master, nothing to commit down here, but your branch is ahead of the remote branch, which is the one on GitHub that all of your teammates are sharing with you. So like I've committed this change, but no one can see it yet because I haven't synced it with GitHub. So in order to sync it with GitHub, I need to use two new commands, git pull and git push. So pull pulls changes from GitHub down to your computer, and pushes changes from your computer up to GitHub. So because something may have changed while I was working on it, I'm always going to git pull first so that I'm getting the most up-to-date version of the code. So it's not going to, I don't want to actually do this. It's trying to autocomplete. I'm not actually git pull or git master. Okay, whatever. So git pull, and it says, oh, wow, okay, so there were changes. And what this is telling me is like blah, 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 blah. It downloaded a bunch of things. Okay, master is the branch that has changed, which is the branch I was working on. Again, don't worry too much about that. I'll talk about branches later. And it says, okay, it was auto-merging robotplayer.java, but there's a merge conflict, which means me and one of my teammates, probably Arvid, has changed the same code, and it doesn't know. Automatic merge failed. Git can't automatically merge this. It doesn't know what to do. We both edited the same line, and now I have to like figure out how to deal with that. So if I go back into robotplayer.java, I'm going to see some scary things here where it's like, what this means is head. So this is me. Head is the most recent commit. So like again, if I type git log, you can see head right here. That's the version of Git that I'm looking at. If I were to like go back in time or something, then I would move head, which is where I am, where my head is, where I'm looking, back in time to a different commit. Right now it's at the most recent one. So it's telling me that in my version, this is what I have, which is nothing at all. And in Arvid's version, the remote version that's on GitHub, all of this extra code is there. And it looks like, okay, so this is where the merge conflict probably happened. He added this comment here, lol, this is probably going to cause a merge conflict. And so since we both edited that, I deleted the code and he modified it. Git says, I don't know what you want, but like here are the two versions, so pick one. And in this case, because his comment is probably not essential and doesn't make the bot better, I'm going to delete Arvid's version and keep my version, which is empty. If I had replaced it
with something else. So maybe I'd put my own comment, like removed stuff here. Then this is what it would have looked like. So if I had added this comment before the commit, then it would tell me, oh, on your version, this is what you have. On the remote version, this is what it is. But we don't need what's on the remote version. We're going to keep the version that we had. You can also keep any combination of it. Git really doesn't care. All Git is going to do is you're going to make some changes to this file, and then you're going to tell Git, done merging. And then Git will be like, okay, that's the new version, and then save it. So you can resolve the conflict however you want, and Git will often merge them automatically. So for example, if so Arvid may have also made some changes to the try move function. If he had made some changes down here, then Git wouldn't have even complained at all. It would have just auto-merged it for me, and I wouldn't have had to worry about anything. But since we edited the same place, and this happens a lot, it says, okay, you guys both edited this, do something about it. Okay, but now we've resolved the conflict, so there's no cause for alarm. We can type git status and see what the heck's going on. And Git tells us, okay, your branch and what was on master diverged, which is what we know. That means that Arvid made some changes and pushed them before I pushed my changes. We have different commits. That's okay. We've used git pull to merge it in. And so now, okay, we're in the middle of a merge. We have some unmerged stuff. This function is what we both modified, this file is what we both modified, robotplayer.java. And when you're ready, git commit to signal that you're going to create a new commit, which is the merged version. So now if we type git commit, it says error. Oh, because I didn't add. You always have to add. So git add, and this time I'm going to use -a because I don't want to type robotplayer.java. And so if I type git status again, then it says, okay, all conflicts have been fixed, but you're still merging. Use git commit to conclude the merge. So now we can do git commit, and it automatically, so now the commit message, if you remember, I had to type it before, but since this is a merge, Git automatically makes this commit message. This is the same screen as before, but I don't even need to write anything. I can just save that file, and now we're good. So if I type git status, my working directory is clean, but now I'm 2 commits ahead of master. Because I have the original changes that I made where we improved robot player, and then I have the other commit that we just did merging Arvid's changes in. And I still haven't pushed any code to the cloud, to GitHub yet. I just downloaded the new version from GitHub. So what I can do is I'll git pull again just to show you that I'm already up to date, which is great, which means I can git push. So git push is where I'm finally taking all the code that I have that GitHub doesn't know about, sending it up to GitHub, and it says, great, you were successful. So now Arvid can git pull and get all my changes and then keep working on lecture player. And so that's like the basic workflow for collaboration. You make some changes, you commit, you pull, resolve any conflicts if Git doesn't do it automatically, and then you can push. And this is great. So now you and the rest of your team can work on the same file on your local machines. You don't have to copy and paste from Google Docs, and you can just git and push and pull these small changes, which mostly won't conflict unless you're editing the same place. And so that's great. And if we go back to, and you can always see the current state of things on GitHub. So like if I look at the current commits, I can see the ones that I just pushed. So Arvid had made, this is the change that we had a conflict with. This is the commit that we made, make miners mine soup. And then this is the merge commit where between this one and this one, I did the pull and resolved the conflicts and then made this new commit and then pushed it all. And so now it's on GitHub. So great. And if we were to look into robotplayer.java, we would see that it has the up-to-date stuff that we added in run miner here. Okay, great. So that all worked. It's now synced with GitHub. My entire team has access to those highly beneficial changes. Let's or actually, does anyone have any questions about that workflow or anything so far? Yeah.
On that page, what are those red X's that committed 3 minutes ago?
Oh, this is there an automatic? I don't know why the red X's are supposed to come up if you have like automatic testing and it fails the tests, but there are no tests. And some of them don't have X's, so I don't really know. Yeah, good question. I don't know what the red X's are. They're safe to ignore, even though they're red. Oh yeah. Oh yeah.
How would you know if somebody else has made a change that you need to incorporate in?
Right. So the question is, how do you know when someone else has made a change that you need to merge with what you've done? The answer is there are Git commands for that where you can like fetch. Git fetch is where you can like get the changes without automatically merging them. Honestly, I never use git fetch. You can always just git pull before you push anything. Always git pull, so that you because if you try to push and there are other changes, then like it won't work because you're out of sync and everything. So just always git pull before you push. If there are changes, git pull will merge them with yours. And you might have to do some manual merge conflict stuff. And then you'll be able to push and you'll have a strictly more up-to-date version, so it'll all work. If you really wanted to, you could also look on the website for if there are any commits that you don't have. But the main workflow is just always pull before you push. Okay, any other questions or questions from Twitch? Any questions from Twitch, Ashley?
Not that I've seen.
All right. Sounds good. Okay, well then let's keep improving. So far the miners just move around randomly, and if they happen to hit some soup, then they'll mine it. If they happen to make it back to the HQ, then they'll deposit it. But we can do a lot better than that. We would like to at least automatically go back to the HQ because we know where the HQ is, even if we don't know where soup is. So after they mine some soup, they should go back to the HQ. So the way that I want to do that is we can save the location of the HQ as soon as we spawn, because the HQ is the only one that can spawn miners. So let's just add some stuff to the run miner function. I'm going to add a field up here. So map location HQ lock, and this is going to start out undefined because we don't know where the HQ is, but we'll try to find it here. So we'll say I'll just add it all in line. So we'll start with if this dot HQ lock, so that's going to refer to the field that I just made up here. HQ lock, similar to Python's self dot whatever. So if this is equal to null, which means that it hasn't been defined yet, we don't know the location, then we need to search surroundings for HQ. Okay, great. So, oh yeah.
Does the template update if there are changes to the scaffold? There's someone new who did it.
Oh, that's a good question. I don't think the template updates if there are changes, right? Okay, so the question was, the Battlecode scaffold repo is labeled as a template, which means that we wanted you to copy that and make your own changes inside there. Unfortunately, changes to the template I don't think will be synced if you made a copy. So the better practice would be and I'll actually just show you right here. We can take the scaffold and so now this is what the initial git clone was for. So if you I'll just put it in downloads. Okay, so if you wait for my computer to load. One of the ways that you could have downloaded the scaffold is by git cloning it like this. So now I have a Battlecode scaffold folder, and it's here, and it has, oh, this is tiny, sorry. And it has the example player, or example funcs player in there, as you can see in the source folder. So this is what you could have done, and then if there is a change to the scaffold, then you can git pull changes to the scaffold. Fortunately, I'm already up to date. But if you use clone, then you can pull things automatically like this. We don't expect to change the scaffold much, but it might be useful to do that. But then what you can do, so instead of collaborating with your team on this entire scaffold repository, which has all this like useless, I mean not useless, but unrelated stuff, like Gradle and all that, like you don't have to worry about that. It would be much nicer if your shared repository looked like this, where like all you have is robotplayer.java, and that's what you collaborate on, and that's it. So the way that you can do that is, I just made a completely fresh copy of the scaffold, and my computer is going slow again. Okay, I made a completely fresh copy of the scaffold, and I can just go into the source folder and git clone the lecture player, and now I have two robots, example funcs player and my team's player, lecture player. And look, I am back in here. I can do git status, and it tells me, oh, I haven't made any changes. Great. And now this repository is like much cleaner than if you had just made a copy of the scaffold. So this is how I would recommend setting it up: is like copy the scaffold separately, make your team repository just have robotplayer.java in it, and then you can copy it right into the source folder, git clone it in the source folder, and you're good to go. Okay. So let me remove that. Okay, great. So back to, oh, right. Any other questions from Twitch while we're answering Twitch questions? Okay, great. Okay, so back to what we were working on, which is finding the HQ location. Okay, so we want to look at the surroundings. So let's first say, we can just check each tile. So we'll copy this for loop that we have here, and we'll check each of these directions for, or no, it would be easier as if we'll do a better example. So we can get all of the nearby robots. So I think there's a get nearby. Oh, right. The other important thing to demonstrate is, so whenever you're trying to figure out how to do something like I am, which is get the nearby robots, a good place to go is the Battlecode docs. And they live at Battlecode website, which is being slow because I'm streaming. And we want to go to the resources, Java docs. Okay. So this is the documentation for all the stuff that you have. So what we want is we want to go to the robot controller and find the function that gets you the nearby robots. So this is really tiny, but we have all these different things like can mine, can deposit, can move, like get map height, get map width, which are new, stuff like that. But we want sense nearby robots. I know the name of it, but you could just look for it. So we're sensing the nearby robots. What we could do is just get all of them, and that's what I'm going to do. So there are many different versions of this function. I'm going to take the one that takes no arguments, because this will just give me all of the robots that I can see in my entire sensor radius, which is fine. And this is going to return an array of robot info objects, which we can learn about from the docs also, but I'm just going to put it in here. So robot info array. This is the type. It's an array, which is these things, of robot info objects. We can give it a name, robots creatively, and then we can say rc.sense nearby robots. Okay, so now we'll get a list of all the nearby robots, and we want to iterate through them. So I can copy this for loop notation, but instead of a direction, it's going to be a robot info, R. We can name it robot, because that's better. Okay, so robot, and this is in the list of robots. So this is, again, a for each loop. This is the list, or this is the list, and this is each element of it. So now we're going to loop through all of the robots, and for a single robot, what information can we see? Well, we have to go back here and look at robot info. So robot info has a bunch of different fields. It has the ID, the location, the team, and the type of the robot. We're interested in the team, type, and location. So we want to check if our robot.type, which is this field, is equal to robot type dot HQ, which again we've imported and using it the same way as we are down here. So if the type is an HQ and robot.team equals rc.getTeam, which is the team of the current robot, the team of the current robot. So if it's an HQ and it's on our team, then we want to save it, and this .hq lock we'll set this to the robot.location. Location. Okay. Great. So now we're going to, every time that the miner has a turn, if it doesn't know the location of the HQ, which is what this one checks for, if it doesn't know the location of the HQ, it looks at all of the robots that it can see in its entire sensor radius, loops through each robot, and if that robot is an HQ and it's on the same team, then we'll save its location, and now we know where the HQ is. Great. Okay, so we'll save that, and let's run a match just to see if anything's broken. So we'll open up the visualizer and run example funcs player versus lecture player on central soup. And okay, great. So we have an error. And it tells us it's too small for you to see, but it says that a non-static variable cannot be referenced from a static context. And I don't know why I don't know exactly the rules of Java's static things, but this is why everything is static. And we can just fix it by doing this. So again, static means that there's only one copy per class. And the reason that static functions aren't allowed to access non-static variables is because the static function is supposed to be the same for every copy of the class, which is the point. And if a function is modifying some single instances data, so if this map location isn't static, then every time you create a new robot player object, it'll have a different copy of HQ lock. So we're not allowed to have static methods edit the individual copies of things. This may seem like a silly restriction, especially coming from Python, because Python lets you do whatever you want. But it's actually pretty nice because it means that you, the programmer, have to explicitly allow which functions edit which things, as opposed to accidentally modifying one variable for all instances. So if it were the opposite way, if an instance method edited a static variable, then it would change for all copies, which can, not be what you want. But long story short, we just needed to throw a static in there because we're using it in a static method. So all of your things will be static, and that's okay. So let's run it again. And sorry, does anyone have questions about the whole static thing? I didn't explain it all the way because it's kind of like annoying to have to worry about, and you don't have to worry about it. Yeah, in the back.
I'm trying it and it says modify static not allowed.
Oh yeah, you're right. Oh, I declared it in the wrong place. Sorry. Thank you. Okay, so I was being dumb, and I was trying to declare, this is silly. I was trying to declare a field of this object, the robot player object, inside one of the functions, which is not what you're allowed to do. I need to declare it here, where the other ones, like turn count, are declared. And so now, like how turn count is used here, I can use HQ lock down here, hopefully. And the answer is that I cannot. Non-static variable, this, oh, right, the problem is this. I don't need, because it's static, I don't need this. This refers to the single object, and since it's not static anymore, it's shared for all copies of the class, which is okay because they're run individually. So a static variable isn't going to be shared between your robots because each one is like in its own little box in the engine. If we wanted to make a lot of copies that could all sort of interact with each other, then the static thing would matter. But since they're all individual, it doesn't matter. And now it should actually work. But I spoke too soon. Okay, so now we have a different, this error, so you can't read it, but it says incompatible types, which is fantastic. This is one of the reasons that Java is great and Python can't protect you. So what I tried to do was I said, if robot.team equals rc.getType. In Python, if you tried to do this, it would say team is blue, type is minor. No, those aren't equal. Continue, right? But in Java, it says you're comparing things that are of different types. What are you thinking? And fortunately for us, I was just wrong. And what we actually wanted was get team, not get type. So thanks, Java. Okay. Great. Now that all those bugs are out of the way, we can run our game, and we should see the same behavior as before, but if it doesn't crash then or throw any errors, then it means that the HQ stuff isn't broken, and in fact we should put a print statement in here so we can actually test it. So if the HQ location is known, then we'll system dot out dot println. Now we can test if it worked by saying HQ location and then HQ lock. Okay, and so this should print it out, and let's start a new game so we can see the print statements. And all of our miners should print the HQ location every turn if we have implemented this correctly, and we can check if it's correct as well. While this is running, does anyone have any questions about anything so far? Or Twitch? Great. All right, let's look at what's happening. Okay. So if we're right here, we can see what is the HQ's actual location, 3737. So now if we look at this robot and we look at its logs, we can see it's printing HQ lock 3737. Fantastic. So now all of the miners know where the HQ is. Okay, great. That was an important step. So let's, I'm going to close this just because it'll make everything else faster. So now that we have the HQ location, I'm going to remove this print statement because we don't really need to print it every turn. And we can maybe commit what we've done so far because we're at sort of a logical stopping point. So we'll say git status to see what's going on, git diff, and now we can see, okay, so all the things that we've changed are we've added the map location HQ lock, and we've added this block here, which will find the HQ location as soon as we can. Okay, so I'm gonna git commit, so git add -a, I need to add the changes first, and then git commit, and I'm going to add the message inline this time. So make miners remember HQ location. And so what this -m flag does is just, instead of opening a file that I have to edit and then save, I can just put the commit message right here, and I'll put enter, and it did the commit. So if I type git log, I can see there's a new commit here at the top of the log. If I do git status, I can see I'm ahead of origin master, which is GitHub. So I'll pull. There have been no changes, so I can just push. And great, now the rest of my team can use miners that know the location of the HQ. Okay, let's do something with the location of the HQ. Alrighty, so what do we want to do? We want to say if you have the maximum capacity of soup, then go back towards the HQ. So we can check that with rc dot, I think it's soup carrying, but we can check the docs. Get soup carrying. Okay. So, sorry, it's being slow. Okay, so rc.get soup carrying is at the maximum. And I could put 100, which is the maximum, or we could go to robot type here, and, or not robot type. What's the, I think there's the max soup. Oh, it's in the game constants, of course, okay. So game constants should have the maximum soup that a miner can carry. Once it loads. And soup limit. Oh, soup limit. Where was that? Soup limit. Oh, that was, oh, actually I was in the right place before, robot type. So the game constants are in two different places. The like global game constants and stuff like that is in game constants. The robot specific constants like the vision radius and stuff like that are in robot type. Sorry for the confusion there. So if we look here, soup limit, we can just say that the miner.soup limit. Okay, so we can go and get the robot type dot miner. So this is an object which has like all of the information about the robot type. And then we should be able to say dot soup limit. Or sorry, get, we can do it the more general way. So we can do rc dot get type. And then dot get soup limit, which is the same thing as doing the miner version. But this is just sort of, I don't know, more general, I guess. So if we're at the soup limit, then let's just print something, and so we can test if this worked. System.out.println at the soup limit, and then we can print out the soup carrying. So get soup carrying, and we can test if this works. So let's run another game and see if that print statement is happening. Oh, did I make it a typo? Oh, yes. Semicolon expected, as always. Okay. I forgot to put a semicolon at the end of this line, which is something that Java makes you do. There are reasons, but cannot find symbol. Get super. Oh, right, because the robot type is a constant. It doesn't have fields. I need to go back to the docs, and this field summary is for constant summary. This should just be a robot type dot soup limit, I think. Sorry, everything is so slow because I'm streaming. This should just be RC or robot type. Robot type dot soup limit. Oh, it's not get soup limit, it's just soup limit. I'm not sure if it's this or the other thing, but I'll just test it. Yeah, okay, great. It's just robot type dot soup limit because this is a property of the robot type class, not of a single type of robot. It would make more sense to, okay, forget it. I'm putting 100. This is bad practice, but I don't want to think about this right now. I'll update it later tonight with the correct thing, but for now it's 100. So we'll run the game, and it's going to fail again. Okay. Just restarting the client because sometimes that does it. Alright, lecture player and central soup. Run. Okay. Alright. So this time it's actually working. Great. And we can check this print statement and see if, okay, yeah, so this one is at the soup limit, 100. Amazing. Okay. So now we know that our miners can recognize when they're at the soup limit, and the last thing to do is to get them to go back towards the HQ. So, let's do that here. So what we really need is the direction to the HQ. Fortunately, we have the documentation for map locations, and there is a direction towards function. So if we look in map location here, we can see a bunch of useful things for manipulating map locations, and one of them is direction to. And this will return a direction. So what we can do is we can go back to the to the code and say direction dir to HQ equals, and then we can say rc rc.get location. So this is the current robot's location dot direction to, and then that takes another map location, which is going to be HQ lock. So now this should get the direction towards the HQ from our current location, and we can try to move, or try move in that location, dir to HQ. Great. And then if that doesn't work, we can try to move in a random direction. Okay. Yeah.
Will there be a guaranteed soup spawn near base and are maps randomly generated?
The questions are, do we guarantee that there's soup near the base? The answer is yes. And the other question is, are maps randomly generated? And the answer is no, they're pseudo-randomly generated by us making maps. So no. You could make random maps if you wanted to. We're planning to put out some instructions on like how to build your own maps in the coming days. But unless we get really tired of making maps or something, we're going to make all the maps for tournaments and stuff. And we'll be adding some more this week also for you to practice on. Okay, so otherwise, move randomly as usual. Okay. So I'm going to add a comment up here because that's good practice, which is going to be time to go back to the HQ. Oh, how did that 4 get in there? Okay, time to go back to the HQ. So it'll try to move towards the HQ. Otherwise, it'll say I moved randomly. And if we really wanted to keep this constant style, we can say if this move succeeds, then we can print system.out.println moved towards HQ. Okay. So let's see how that goes and run another game. Okay, runner. So let's run. And I wonder, oh, you know, this is Electron. I might be able to make it bigger. No, I guess not. Okay. Sorry you guys can't read what's on the screen. But if we take a look at what's happening later in the game, we can see, okay, so this miner just mined some soup, and oh, it moved too fast. Hold on. Let's let it load a bit, and then we'll keep going, so it's a bit smoother. Okay, so the game is now ended, and it should play back a little smoother. So we can see that this robot mined some soup, and I'm gonna step one at a time, just so we can see this a bit better. So this guy right here looks like he's mining some soup. So we'll see what he's saying. So yep, he's a miner. He's mined 70 soup. This button just steps through one round at a time. So he's mining some soup here. Great. That little block just disappeared. So now he's full, and he's going straight back to the HQ. And it's printing, move towards HQ. Great. And so now that miner is going towards the HQ. Refined a bunch of soup. And now, look, we can see there's some pollution around the HQ because it's refining soup, and that's what happens when you refine soup. So if we keep going, we'll see that this thing will probably get depleted. The HQ is going to produce pollution from time to time as miners bring back soup to get refined. The miners still wander around randomly when they don't have any soup, but when they find some soup, they bring it straight back to the HQ. And if we look at the game, blue team has way more soup than the red team and way more units because it's vastly superior to example funks player, clearly. Sorry? Exactly. And so blue team has won this one by a landslide with 14 units and 54 soup left, and red team only has 4 miners and 6 soup. Of course, they could have done better if they'd protected their HQ from the flood, but at least we're winning on the tiebreak now. So great. Okay, this is fantastic. So we should commit this so that the rest of the team can benefit from this really high level behavior of bringing soup back to the HQ. So we'll go back, and once it learns, we can check our git status again. Oh, but not there. Can check git status here, and it says, okay, we've modified RoboPlayer. Okay, so what has changed? Okay, so instead of just moving randomly, now we have this if-else thing. So I guess I should have said, similar to Python, Java has if-else control flow. I'm gonna, just so it's clearer, add parentheses here, or add, not parentheses, curly braces. Java will execute, if there are no curly braces, Java will like execute the next line as if it's inside the curly braces and then just keep going. But in case I wanted to like add another line here, I don't want to forget to do curly braces, because then so actually I'll just show you. So if I didn't have curly braces and I added a line of code right here, which was like system.out.print blah 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 blah. So if I added this line, then if this if statement was true, it would execute this, and then it would continue this line, which is what I expect. But if this if statement is false, then it will skip this line, or sorry, it'll skip this line, and then execute this line. because indentation doesn't matter. The way that this actually is like this, where only this first print statement is actually in the if. So to avoid self-inflicted bugs like that, I put curly braces around everything so that this is logically always inside the if statement no matter what. But anyway, sorry, slight digression about if statements in Java. But yeah, so if else blocks in Java are just like Python ones, but instead of indentation to show what's inside what, you just use these curly braces here. Okay, great. Anyways, so let's go back to our git diff, and we'll see, okay, great, this is all the code that we added. There's nothing else. So we'll commit that. Oh, we can't commit yet. We need to add first, git add. Actually, I'm going to show you a really fancy trick. So there's another flag, A, which means also add everything. So git commit -a is the equivalent of git add -a, so add everything, and then commit. So now I can do it all in one line, git commit -am, and this will even let me put the message in, which is just wild that I can do that all at once. So the message will be bring soup back to HQ. And then if we hit that, we can see in the log that there is a brand new commit that we just made. We can see from our status that we're ahead of master. We'll pull just in case someone else has made some changes. Nope. So now we can push. And now all of that's saved on GitHub, and the rest of the team can benefit from it. So if we go back to lecture player and refresh the commits, we'll see that it'll load slowly, and then our brand new commit is right there. Okay, great. So now the rest of the team has access to these fantastic new intelligent behaviors. I think that's a pretty good stopping point for today. So tomorrow we can start building all other kinds of units and doing stuff with them. Yes.
One, can the robot somehow sense water in its scope or only adjacent?
The question is, can robots sense water only that are adjacent to it or anywhere in its sensor radius? And the answer is anywhere in the sensor radius. You can sense water, soup, other robots, buildings, etc. Any other questions about anything we've talked about today from Twitch or the audience?
I think there's one more on the Discord. That's about the number of HQs. So can a team spawn with multiple HQs, or will you be nice to us and limit our HQ count to 1? LOL.
So the question is, will there ever be multiple HQs? The answer is no. Only one HQ, exactly one HQ every single game until it gets flooded, and then there will be no HQs. All right, any other questions? Okay, so if anyone wants to stick around, I can help you and your team get set up with like GitHub and stuff and collaborating and all that. Otherwise, good luck. Feel free to copy the lecture player and build off of it. It's going to keep improving over the course of this week. But yeah, any questions, feel free to ask. And good luck. Okay, bye Twitch.